All right, so I've got this inequalities quiz we did, and I just want to go over it real quick. If you've got any questions, please let me know. Happy to do some more. So we've got our level 2 questions where we've just got an inequality, and we're asked to graph it and list a couple solutions. So this one just says x is less than or equal to 3. So because it says less than or equal to, I actually will fill in my circle. Oh, that was weird. Okay, let's try that again. I will fill in my circle, and then it says less than, so I'm going to go to the left. Everything less than 3. So for example, 0, -5, 1.2 are solutions. So where it says list 3 solutions for each, you're giving me numbers that work, like -2, or -1,000,000, or 1.3. On the second one, x isn't by itself, so I'm going to subtract 3 from both sides. So -1 minus 3 is -4, and I just keep the inequality the same. X is bigger than -4. Draw an open circle on this one and point my arrow to the right. The reason I did an open circle is because it can't equal -4. It has to be bigger than -4. So numbers that work are like -3, -1, 2.5, etc. Okay, scooting on down. Now we're graphing an inequality, so I'm just thinking about the m and the b. So my b is -2. I'm going to put an open dot there because it's just a less than symbol. It doesn't have the or equal to. And then my m is 2/3. So I rise 2 and I run 3. So rise 2, run 3. So I go up 2, 3 to the right, open circle. Up 2, 3 to the right, open circle. So I'm going to connect that with a dashed line. My boundary doesn't count. Just like in problem 2, I couldn't equal x is -4 in number 2. In number 3, I can't equal an xy point on the line. Now I need to shade everything that is lower than the line because it says y is less than. Smaller y values are down. Just like on our x value number lines, we move left to right. On our y value here, we go up and down. Test a point from the solution region, so anything shaded in, like for example, I could test the point 0, -5. So I take -5 as a y value, and I take 0 as an x value, and I'm just double checking if this is true. 2/3 times 0 is 0, -5 less than -2 is true. So I checked it out, and it is really a solution. Okay, number 3. We're going to graph it, solve it, list some solutions. So first, let's subtract 5 from both sides so we can get our v's by themselves. Then let's divide by -7 on both sides so we get v is greater than or equal to +11. I want you to notice that I switched the direction of the inequality. The only time you do that is multiplying or dividing by a negative. So now we graph it. Closed circle because it is greater than or equal to. Pointing to the right, the number right below the circle is 11. Counting down 10, 9, 8. It's getting a little messy, but this would be like 12, 13, 14. Solutions to this problem would be any number bigger than or equal to 11, like 11 itself, or 11.1, or a billion. On number 2, first thing I'm going to do is add 4 to both sides because that will get rid of -4. Add 4 to both sides. And then how do you get rid of a fraction? You just multiply. Multiply both sides by 2. I don't need to change the direction of my inequality. So there's 22. There's an open circle. X is less than, anything less than 22, like 21.9, or 0, or -1 billion. Okay, keep it on moving. Now we've got an inequality that's not in our mx plus b form. So please just notice how this one's in a different format. But I can play a similar game. I can think 2x is less than 6 means if I just think about the x number line, 2x is less than 6 means x has got to be smaller than 3. I divide 6 by 2. 6 divided by 2 is 3, and I put an open dot there because it's just a strict less than. 3y is less than 6. Well, that would mean y has to be less than 2. So I put an open dot there. And you can actually see that I've already got all the information I need to draw my line. I can see that my line goes down 2 and 3 to the right. I can also see it has a y-intercept of 2. If I wanted to, I could rewrite this inequality as y is less than, it goes down to over 3x, and it has a y-intercept of 2. I'm going to shade below the line because it said y is less than 2, and it says x is less than 3. So that's why I want to go in that direction. I could test any point in the shaded region. The easiest one is 0, 0. If I go 2 times 0 plus 3 times 0, is that less than 6? Let's check. 0 plus 0 is less than 6. That's how it works. Okay. Now we've got a word problem. Connor goes to the carnival, $32.50 total. He bought a hot dog and a drink for $3.75. And he wanted to spend the rest of it on ride tickets, which cost $1.25 each. We don't know how many he bought, so I'm going to put a variable on there. I'm going to say that x is just the number of tickets. He can't spend more money than he has, so the amount of money has to be bigger than, or it could be equal, he could spend all of it, to the hot dog and the drink plus the ride tickets. So let's subtract. So we're getting x by itself. So if we subtract, we get, let's see, 28.75, bigger than or equal to $1.25x. Then we divide by $1.25. And what does that come out to be? Come on, calculator. 28.75 divided by $1.25, 23. So 23 is bigger than or equal to x, which is the same as saying x is less than or equal to 23. You can't buy more than 23 tickets. So you got 23 with a filled in dot that you're buying less than. You can buy 0 tickets. You can buy 23 tickets. Anything in between. Okay, almost done. Now we got this weird double-sided inequality. Basically the same idea. Let's just subtract 3 from everything. -3 minus 3. The middle chunk minus 3 gets rid of a plus 3. The chunk on the right minus 3 becomes 2. All I did was I got rid of a plus 3 by subtracting 3 from each of the 3 pieces of the inequality. Then I'm going to divide everything by -1 to get x by itself. When you divide by a negative, you got to switch the direction of your inequality, and you have that left over, which is just showing you that x is in between -2 and 6. At -2, I've got a filled in circle, and that's -1, 0, 1, 2, 3, 4, 5, 6. At 6, I got an open circle, and anything in between works. Like, for example, -2 works, or 0 works, or 1 works. Last problem. You're trying to raise at least $100 by selling necklaces. You can sell a necklace for $5, but you have to pay a $10 fee for each farmer's market they attend. Okay, so let's say that I get $5 necklaces, and we lose $10 per farmer's market, and we want to raise at least $100. Now I want to point out, the way that I made y and x stand for stuff, it's just random. I made the y stand for necklaces, and I made the x stand for farmers markets. But there was no reason to do that. You could have done it the other way. If you do that, I can add x to both sides. I get 100 plus 10x, and then divide by 5, and I get 20 plus 2x. And so then that lets me know how I can graph it. Maybe let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then if I'm counting by 2s, I have a slope of 2. So I'm going to go up 1 over 1. So because each of my boxes counts for 2. So my y-axis is counting by 2s, and my x-axis is counting by 1s. And I'm going to shade everything that is above that line, because that's what I want to do, is I want to shade more necklaces. I want to sell more necklaces and not go to too many farmers markets in this situation. Okay, so one combination that would work is I go to one market and I sell, say, 50 necklaces. Or I could go to 5 farmers markets and sell 100 necklaces. That would get me enough. Or I could go to 2 farmers markets and sell 1,000 necklaces. Okay, let me know if you have any questions. Thanks for watching.